Hello viewers, welcome to today's episode. This is Josie Science Academy. If you are joining us for the first time or this is the first time you are watching this channel, thank you for stopping by. And if you have subscribed to this channel and been following up these classes, thank you for always watching my videos. My previous video I made on vectors, resolution of vectors precisely. I was able to explain to you how I was able to tell you how we can resolve vectors, a particular vector, that is one vector, into horizontal and vertical components. So today we want to see how we can resolve more than one vectors. That means if you have more than one vectors, how can we resolve them into horizontal and vertical components? So let's look at what we have on the board. Resultant of more than two vectors. To find the resultant of more than two vectors, we resolve each vector in two perpendicular directions. Add all the horizontal components x and all the vertical components y. So what is it trying to say? Now, for example, looking at the diagram we have on the board, we have four vectors: f1, f2, f3, f4. And we want to resolve these four vectors into horizontal and vertical components. So it's trying to tell us that we are going to resolve all of them in the horizontal component first, and then resolve them again into vertical components. So watch out and see how we are going to do that. If you want to resolve this into horizontal components, I will say that this is vertical. So this is y and what? Minus y. Positive y and minus y. This is positive x and what? Negative x. So the horizontal component is positive x and negative x. So it's going this way. Okay? So if I want to resolve these four vectors into horizontal components, we must make reference of the vectors that are in the negative side of the horizontal and the one that are in the positive side of the horizontal. Is that okay? So looking at it now, this is positive x. It means that f1 and f4, they are in the positive side of x. So that means two of them are what? Positive. And mind you, when we are resolving in the horizontal component, we assume that the vertical does not exist, so that don't bring confusion. So in a nutshell, you can just know that the vectors f2 and f3, they are on the negative side of what? X. Automatically they becomes what? Negative. And the vectors from here to here, they are in the what? Positive side of x. Automatically they becomes what? Positive. I hope you get it now. Okay, then you should also remember that horizontal deals with cos while vertical deals with sine. If you bear that in mind, we see that I want to resolve this into horizontal components. This f1, remember, it is positive, and this is what? Positive, because they are the positive side of x. So this is what? Negative, and this is negative because they are the negative side of x. So you are going to say that this is what? F1, that is this, cos what? Theta 1, cos theta 1 plus F2 is negative. I will say bracket minus F2 cos theta what? 2, right? F3 is also in the negative. I will say plus bracket minus F3 cos theta what? 3, right? This is what? Negative. So I will now go to this one, plus f4 cos theta what? 4. I hope you get this now. Now we are able to resolve all of them into what? Horizontal component at the same time. Okay, so let's look at the vertical component, which is what? Y. Look at vertical. Vertical is what? Up and what? Down. Up and down. And if you are resolving the vertical component, we assume that the horizontal does not exist. How do I mean? You can cover this side this way, so that f1 and f2, they are in the positive side of what? Y, which is this, positive. Y, f3 and f4, they are in the negative side of what? Y. Is that okay? So when we are moving, we must make reference of positive and what? Negative. In other words, that means we are resolving all at the same time. Okay, so let's go. And remember that vertical goes with what? Sine. So this is f1 sine theta what? 1 plus f2 sine theta what? 2. Okay, these two are in the positive side. That is f1 sine theta 1 plus f2 sine theta 2. Then these are negative. I will say minus bracket, sorry, plus minus bracket f3 sine theta 3 plus bracket minus f4 sine theta 4. Okay, so when we are able to solve these ones, we add them together and get the total x, that is the horizontal component. Then also add it together to get the total y, that is the vertical component. Then at the end of the day, we use right angle vectors to solve to get the total resultant. So let's look at an example on the board. Stay tuned. So let's look at this problem on the board. We are given this diagram. We have a force of 10 Newton, 12 Newton, 20 Newton, 16 Newton, and 15 Newton. We are asked to calculate the resultant force. For us to calculate the resultant force, we have to take some things into consideration. Okay? The first thing we are going to take, we are to note that all horizontal vectors must be inclined at what? 0 degrees. Which one is a horizontal vector? Any vector that is lying on the horizontal is said to be what? Horizontal what? Vector. Okay? And it is inclined as what? 0 degrees. Now, number 2, all vertical vectors must be inclined at what? 90 degrees. This is a vertical vector. So this 16 Newton is on the vertical. So automatically its angle is what? 90 degrees. That means the angle here is what? 90 what? Degrees. Is that okay? Now, for us to be able to solve this, we should also know that all the angles must be inclined to the horizontal. Now look at this 30 degrees. It is inclined to the vertical. But we are not going to solve with this angle. The angle we need is this one. So because this is a right angle, we will subtract by saying that 90 minus 30 to give us what? 60. So for this particular vector, we are using angle of what? 60 degrees. And remember that when we want to resolve these vectors, we resolve all of them into horizontal components at once or at the same time. Then we also resolve all of them into vertical component at the same time. Okay? All right. Okay, so what we are expected to do next is to resolve all of them into the horizontal component at once. Then we resolve all of them in the vertical component. And as we are resolving it, we should also recognize those vectors that are in the negative and the ones that are in the what? Positive. For example, if I use this, so we will consider this 4 cardinal points. This is plus y and this is what? Minus y. This is plus x and this is what? Minus x. Okay, so what we are going to do is to consider the vectors that are in the horizontal component using this. Any vector that are between here and here, they are all what? Positive. And the vectors between here and here are all what? Negative. So looking at this question now, we already know that 12, 10, and 15, they are in the positive side of what? X. If you are considering the horizontal component first. Okay, then 12, 20, and 16, they are in the negative side of what? X. So these two will be what? Negative. While these three will be what? Positive. I hope you understand that now. Then also remember what I told you, that all horizontal vectors are inclined at 0 degrees. That is, 10 is inclined at 0 degrees. And all vertical vectors are inclined at what? 90 degrees. That is, 16 is inclined at what? 90 degrees. Is that okay? And all angles must be inclined to the horizontal. What do I mean by that? If the angle given is touching the vertical, the one we need is the one touching the what? Horizontal component. So we are going to horizontal rather. So we are going to use 90 to subtract to get this one. Is that okay? So let's go. X x is equals, I'm starting with this one. This is 10 cos 0 plus 12 cos 50 plus bracket minus 20 cos 40 plus bracket minus 16 cos 90, then plus 15 cos 60. Okay, this is the horizontal what? Component. So let's work it out. So we'll go 10 cos 0 is equals to 10, that is 10 plus 12 cos 50 is equals to 7.713 plus bracket 20 cos 40 is equals to minus 15.32, okay, plus bracket 16 cos 90. I will have minus what? 0. Then plus 15 cos 60 is equals to 7.5. So let's add all together to see what we have. We're going to add all together, okay? So 10 plus 7.713 plus times minus is minus. I will say minus 15.32, then minus 0 plus 7.5 is going to give me plus 9.89. That is for what? The horizontal component. So let us add all the vertical components together. That becomes my y. Then this y, it will be considered the vertical, it will be considered the positive side and the negative side. So this is the positive side of what? Y. This is plus. That means 10, 12 and 20, they are the positive side of y. So they are all positive. When we consider the vertical component, 15 and 16, they are the negative side of what? Y. So they are all negative. So don't forget that. So let's go. We are starting with 10, then we'll go this way. And remember that vertical goes with sign. So I have 10 sine 0 plus 12 sine 50 plus 20 sine 40 plus bracket minus 16 sine 90 plus bracket minus 15 sine 60. So let's solve it again. Let's calculate. 10 sine 0 is going to give me 0 plus 12 sine 50 equals to 9.19 plus 20 sine 40, we have 12.85, okay, plus bracket 16 sine 90 is equals to 16, that is minus 16 plus bracket 15 sin 60. I will have minus 12.99. So let me solve them together. 9.19 plus 12.85 plus times minus is minus. Okay, sorry, 0 is not in anyway, so we can say 0 plus 9.19 plus 12.85 plus times minus is minus. I will say minus 16 plus times minus is minus. I will also say minus 12.99. So it's going to give me minus 6.95. So we have gotten the horizontal component to be plus 9.89, then the vertical component to be what? 6.95. Alright, so now we have gotten them. The next thing we are going to do now is to resolve them using a right angle what? Vector, or vector in class as what? Right angle. So let us look at the resultant. So if you consider this, we have the positive y and negative y, positive x and negative x. We realize that this x is positive, so it is in the positive side of x. Then our y is negative, it is in negative side of what? Y. So we are considering this quadrant, this and this. Okay, so you must consider that if your cardinal, if your x is positive and your y is negative, or if your x is positive and your y is negative, you must consider that to know how you can get your resultant and equally your direction. So if you do that, we have this. So my x is 9.89, that is plus, while this one is minus 6.95. Looking at this now, what you are going to do next is to complete it and solve it like a right angle vector, because it's not right angle. So if this is parallel to this, here is 9.89. Okay, so we join it together to this point and call the line what? R. So this is for my direction. For us to get the resultant, we are going to use Pythagoras theorem, which states that what? R square is equals to f1 square plus f2 square. Okay, so let's put in our value. R square is equals, what's my f1? My f1 is what? 9.89 all squared plus bracket minus 6.95 all squared. So let's work it out with our calculators to see what we have. 9.89 squared equals to 97.8121 plus minus 6.95 squared equals 48.3025. So let's add them together to see what we have. Remember, when you square a negative sign, it will change to positive. 97.8121 plus 48.3025. So I have 146.1146. To get my R, it will be root of 146.1146. So you simply write or press root answer. So my resultant vector for this question becomes 12.08 newtons. So we have gotten the resultant. And because it's a vector, we're certainly going to look for our what? Direction. Before we solve the direction, if you're watching this channel for the first time, please do well to subscribe and like this video for more educative videos so that other students can see it and learn from there. So let's solve for the direction. Our direction, we are going to use tan. Tan is opposite over what? Adjacent. So we say tan alpha is equals to 9.89 divided by 6.95. Okay, so we are not going to work with the negative again because we have known that it is going the negative direction. That's all. Okay, so let us divide and see what we have. 9.89 divided by 6.95 equals to 1.423. Okay, so this is 1.423. My alpha is the direction. I'm going to say tan inverse of 1.423. So that is shift tan 1.423. So the alpha is going to give me 54.90 what? Degrees. Then you must indicate where it's going to, whether it's coming from north or whether it's coming from south, and where it's heading to. So this is what? South, and this is east. So the direction is equals to south 54.9 degrees what? East. So this is the direction of this resultant vector. I hope you understand. So this is the method we can use to find the resultant of more than two vectors when we have more than two vectors inclined to the horizontal. If you love this video, please subscribe to this channel so that I can be getting more and more of educative videos like this, because I'll be posting virtually every day. Okay, so subscribe to this channel so that I can get notification each time I post videos, and see you next in my next class. Remember to do your assignments and drop your answer in the comment section. Bye.